Hi everyone, Claude from RunChat here. In this video, we are going to look at 8 tips for using Claude to write scripts in Rhino, with the goal of helping you to get closer to the kinds of design outcomes that you actually want. Claude in Rhino is a super powerful tool because that model is very reliable. It will be extremely good at following just about any instructions that you give it and producing an outcome that runs without bugs. But it means that it is up to you to understand how to prompt that model so that what it implements is what you had in mind. And that is what this tutorial is all about, how you can achieve that. So let's jump straight in. So the first tip is to use good coding models in RunChat. You'll often find that there is some trade-offs between using like a really cheap, accessible model and using a good model that costs more credits. But in the end, it's, I think, much more valuable to have a model which works more often so you can iterate faster than it is to try and get a cheap model to do what you want. And here's an example. So we have exactly the same prompt for something that's fairly simple. We're asking for something which requires a script to do. It's going to iteratively boolean some geometry just as a formal study, let's say. We can run that in with Gemini Flash, and it costs 11 credits. It's extremely cheap. We can hit play, and it's saving our Python script, first corner of the base, so it's asking us to generate some box. I already had my box running actually, let's run it again. It's saying select a base geometry, I'm picking that, iterations 10, blah, 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 and we've now got an error. So to fix this, we can send the error back to the console. Gemini will have another go at fixing it. It might take a couple of iterations to get right, and then you'll be fine. But the main issue with this is that it breaks your flow. If you're always going back and fixing bugs, you aren't just exploring whether or not your design idea is good in the first place. So let's see if it's fixed it with this second go. We've still got issues. Okay, so I can run that again. I mean, this is very easy to go back and forward, but the point I'm trying to make here is that it is often cheaper to use cheap models, but it's not faster and it breaks your flow. So let's contrast that with using the exact same prompt with Opus. It's 150 credits instead of 10. When we run this, we're going to select all these options. We get something that runs first try, and we can now go ahead and iterate on that prompt. Okay, so we're getting straight into something which is about design instead of just purely technical. Let's see if Gemini is working yet. We've still got errors. Okay, so this is really, really important. So the second tip, so basically use really good models. They are more expensive, but they might actually end up saving you money in the long run, and they're definitely going to save you time. To get the best value from using these models in RunChat, you can link an Openrouter account. So you go in here, link, and then you can link Openrouter. Then you'll use your Openrouter account to pay for any tokens that you use. That's pretty close to cost price, the same as just using an API key with Anthropic or something directly. I think Openrouter adds a 5% markup or something like that. So that's going to be the cheapest way to use these good models in RunChat. All right, next tip is to plan in chat and to start simple. Okay, so let's see if this can actually help us use these cheaper models to start simple and to plan in chat. So I'm going to grab these, we'll just move these down. And we're going to we'll create a code node. And what I want to do is I want to iteratively boolean this box as a kind of massing study, let's say. I'm interested in something which is going to, over time, be kind of sort of growing this geometry and also subtracting from the geometry just as a study, right? Now, we could just ask for that in one go, which is what we did earlier. But the thing that it made, it was rotating all of the boxes. The boxes were kind of too small by default. I could go configure all those parameters, but it wasn't exactly what I actually had in mind. So what we're going to do this time is we're going to start with something simpler, and we're also going to plan in chat. Okay, so we're going to use a good model. Rhino Python is our output, and we're going to say we're interested in a geometry generating algorithm that iteratively booleans, unions, or subtracts boxes from a base geometry. Can you help me to stage this script? We want to start with something simple that we can easily test before adding more features. And we'll send that. So this is like a superpower. You describe your idea at a high level, and then you ask the model to help you plan how to implement it. The model is going to give you, in this case, Opus is just going ahead and writing an initial script because it thinks what we've asked for is simple enough already. So that's great. It's really simple. But then it'll also help you say, okay, look, maybe some ideas for extending this would be X, Y, and Z, or maybe some of your ideas are like far too complex. Let's break those down. So here we go. It has suggested a couple of things, some good things to test. Subtract chance is 0. That means we have pure growth, or 1 is pure erosion. Try different size ratios, etc., etc., etc. Let's run this and see what we get. Base box size 20, sure. Number of iterations 10. Chance of subtraction half. Okay, nice. We've gone and gotten some addition and subtraction. And now we're going to run this again. So we can run the script again from our script browser. So we can click this in the run chat window, got our save scripts down here. And that'll let us go and find all of the scripts that we've been running, and we can just run it again. So base box size 20, I'm going to make this 50 iterations. Chance of subtraction, let's make it slightly higher. Min random box size, let's make that 5. Max, let's make that 12. Okay, that already looks quite a bit more interesting, which is great. Okay, so let's see what else Claude has suggested. So once you've played with this, we can add features like rotation of the toolboxes, selecting your own starting geometry, weighted placement toward the surface, layer, color control, or undo history. I think what I'd like to do here is, let's say I want to use this as more of like a design tool. Maybe I want some ways of configuring and controlling this. Maybe I want to provide multiple input boxes, or I want to grow this along a curve. So there's a greater random chance that my boxes are added along a curve than they are just purely randomly in space. Instead of prompting for all of that in one go, I would add this sequentially. So we're going to do that. This is another tip. Yeah, start simple, add things sequentially. So let's try one where we want to add boxes which are kind of, or geometry, which follow a curve. So I'm going to draw in my curve here. Okay, and we're just going to say, just continuing on in our chat, we want to be able to provide a curve and have the chance of boxes being added along the curve be higher than randomly space. Now, the next trick is to get the model to ask you clarifying questions. Like maybe what I'm describing here is not clear enough for the model, and we want to make sure that its understanding is actually what we had in mind. Like I'm kind of imagining here that it'd be cool to have this sort of geometry, but generated in a way where I can provide, well, eventually multiple curves, but we're going to do this simply in sequence. So I can just draw a bunch of curves and I'll get this kind of Boolean geometry along my curves. I want to make sure that Opus understands that intent. And so I'm just going to add at the end here, ask me some clarifying questions before writing code. And then we'll just click send. Okay, so this time Opus is going to come back and clarify what we want. This will work with any model. It just works particularly well with the good models. So let's see what we get here. I'm just going to full screen this so we can read it better. Okay, we've got curve as an attractor versus strict path. Should the curve act as a magnet? Boxes are more likely near it but can still appear anywhere, or should boxes only appear along the curve? So we're just going to say, yep, attractor. For 2, attractor strength, do you want the parameter to control how tightly the boxes cluster around? For example, a spread distance. Yes, that sounds good. Spread distance sounds good with fall off. 3, union versus subtract. Should the curve influence the operation type 2? For instance, boxes near the curve should favor union. Boxes far away favor subtraction. Yes, sounds good. 4, curve selection. Should there be an existing curve you select, or would you also like the option to draw or pick one on the fly? Yes, we want to select an existing curve. Curve. I'm just going to put in so it knows what we're doing. We're using a good model here, it'll understand. Multiple curves. So let's say yes. Multiple curves. And should we keep the auto-generated base box, or do you like to select an existing geometry? Let's select an existing. Okay, and we'll hit go. Opus might come back with more clarifying questions here. We'll see. It seems like it's pretty clear, which means that it's going to just confirm. Okay, let's see. Fall off type. All sounds good, go ahead. Okay, now notice that for these clarifying questions, the cost is pretty low. And that's because for these follow-ups, all of the previous prompts that you've been running are all cached. They're really, really cheap. So you don't have to worry too much about this back and forward costing you lots of money in terms of credits. Just go ahead and get everything planned out well before you write code. Again, that'll be cheaper in the long run. Okay, so Opus is now going to go read the current state of our code, and then it'll go make all of these changes. So I'm just going to move this over while we're doing that, and I'll make my box at the start. And let's draw a couple of curves and just see what happens. Two is going to be fine for now, I think. Okay, gone and written all that code. Let's run that. Select base geometry, select attractor curves, number of iterations, let's increase that. Let's just keep everything default. They're pretty small boxes. Okay, I think we need to increase our fall off distance. So let's do that again. Go into our save scripts, run this latest one. Tractor curves, number of iterations, let's say more than that. Tractor spread distance, let's say 50. Tractor weight, union chance near curves, that sounds good. Far short, min box size, let's say 10. Max box size, let's say 20. Okay, that's pretty crazy. Now, I think what we're getting here is too much influence from, we've almost gone and just jumped ahead too much, haven't we? We're getting too much random addition, not enough weight of our curves, and we've got now three-dimensional rotation of the boxes. So this gives us a great opportunity to go to the next step, which is going to be how we prompt the model. Actually, before I delete that, let's use it as a screenshot. How we iterate with the model. So how do we tell it what's going wrong here? So the next trick is to use screenshots and sketches. So what we've got is the model is doing something, but it's not doing exactly what we want it to. Specifically, it seems to be growing down instead of growing up. So I'm going to screenshot that. And I'm going to draw my two sketches and even put a little question mark in here. And we're just going to copy that. And we can paste this copied sketch straight into our chat. So I'm going to chuck that in there. and we'll just ask a follow-up question. So we're going to say, look, it seems like our growth isn't following the curves enough. Let's try a version where the boxes are just like much more tightly pinned to the curves. And we'll hit go. Because we asked for clarifying questions earlier on in the chat, there's a good chance that Opus is going to follow up with more clarifying questions now. It knows that that's the way that we like to work. Or it might be able to just simply figure it out from our sketch. So we've done a sketch here showing, hey, here's our curves, what's going on. Okay, let's go and making a couple of changes to this code. It's got some ideas for how to implement it. And now I'm going to move this out of the way because we've done a sketch. Okay, and we'll run that. Base geometry, tractor curves. I'm going to leave everything other than our iterations default. And see how it goes. Okay, that default size again is too small. So let's try running that again. Base geometry. In fact, also I might try moving our tractor curves a bit closer to that base geometry. Jump in here, run our script. Tractor curves, number of iterations 80. The tractor spread distance, I'm going to increase that 10. Traction weight, yep. Union chance, so this is very high. Okay, min box size, let's make that 10. 15. Cool, that seems quite a lot better. It's definitely growing along curves now. And so that seems to be our just default config that is necessary there. Okay, let's jump back to our scripts and have a look at the next couple of tips. Okay, so the next tip is to use reference images. So in our generated geometry, we've got this kind of random box aggregation, that's fine. I kind of preferred it when it wasn't rotating in 3D actually. And so what we want to do is we're going to start providing some images to the model to help guide it in terms of the sorts of geometry that we create. This is especially useful when the kinds of aesthetics or forms that you want to make are difficult to describe just with text and prompts, but relatively easy to describe by just providing some images of the types of patterns or forms that you want to make. So we're going to use this Scarpa geometry as an example. I'm just going to copy this image and we're going to include it in this chat. So we'll paste it in and we're going to say something like we want to constrain our geometry in a similar way to what we see in the image. So we don't even need to be specific, like saying, oh, we don't want 3D rotations, blah, blah, blah. We're just going to say, make the geometry like this image. Constrain booleaned geometry like in its reference image. And let's just see what we get just from that alone. I'll pause the video while Opus goes and generates the code and we'll come back to it. Okay, that is way better. So I have to admit that we've done a couple of steps here while I've paused the video just to get the effect that I want. And now we can kind of go through how that was achieved. So if we scroll through and have a look, we started with our reference image. The model then interpreted that reference image as being only subtractive. And we had to prompt it like, well, actually, this should be a process where we grow along the curves and then we subtract, which it then implemented. And then we said, when we subtract, we want to do this multiple times to create this stepped effect that we get here. And that was enough to achieve something which is kind of getting close to what we want. Now we still don't have complete control over this, and so that brings us to the next tip. This is a bonus tip. Wasn't planning it at the start of the video, but that is we should always use a GUI. So when we're using the Rhino command line to configure things, this can get kind of annoying. So I'm just going to copy my code editor here, just so we've got like another version of the code that has the GUI in it. And all I'm going to do is prompt and say, let's use a GUI instead of the command line for configuring this. Okay, here we go. The thing about a graphical user interface instead of the command line is you can see all of the parameters at once. We could even prompt it to be able to save these parameters to different presets to make a really useful design tool. This kind of stuff is really, it's just up to your imagination in terms of how efficient you want to make this tool. For something like this, which is supposed to be like a formal exploration tool, I think it is really, really useful and important to have things like presets where we might configure a bunch of parameters, get something we like and want to save that and return to it later. And we can just prompt the model for those sorts of things. So we'll pause this and see what it comes up with. Okay, we've got our GUI. Let's run that one. GUI is graphical user interface. We've got our starting volume, our guide curves, and now we've also got a way to configure everything. So we've got min box size, max box size, spread from curves. All of these are like really important to get right. Like we want this spread to be a bit bigger, this to be bigger, min box to be bigger. Number of boxes is fine, subtraction 30, min cut size, max cut size, spread from curves, terraces. So this needs to be way bigger for max cut size 15, spread from curves also needs to be bigger. Steps per cut, okay, and then we can run. Okay, awesome, that's pretty cool. That time it's actually grown along both curves, whereas before it just grew along one curve. So it's giving us much, much, much more control in this case. All right, last tip. So we ended up with 9, not with 8, is to use the right platform. So here we have a tool which is kind of doing some geometric operations. It's using Rhino's booleans for doing that, and it's one-shotting it. So we set up all of our parameters for the script, and then it runs the script and we get our geometry back that we can see in the viewport. If we wanted this to be more like an interactive simulation, like maybe we want to be able to move the curves around while this geometry is being generated, say, or we want to change the parameters and see the impact of those parameters immediately, it's kind of like more like how you might expect this to work in, say, Grasshopper or within some simulation tool like Houdini or Blender or something like that. We can write code within Blender. That would be one option. Or another option is to write Three.js code. So Three.js is a web library, JavaScript library for doing rendering in a browser. You can make 3D apps with it. And if you want something which is a sort of advanced or more of a complex simulation where you need to interact with something, see things move around, maybe you want to build a sophisticated UI that looks really pretty, you can use HTML as your output type for your code node, and then ask the model to write Three.js apps and see what you get. So let's pause the video and we'll make a similar kind of Boolean generation tool in Three.js and see how that works out. Okay, so we're going to select HTML as our output, still using Opus, and we're just going to say make a Three.js app that generates boxes that randomly grow from an initial box. We should periodically subtract boxes to produce geometry that looks like this. Now, worth noting that we aren't following our recommendations here in terms of we should really still be starting simple, asking the model to ask clarifying questions, all the rest of it. That'll work much, much better. Don't just try and one-shot it like this. But this is just to give you a sense of the difference between the two output modes. So Rhino Python versus interactive HTML apps with Three.js. Okay, so let's go on and written our code. To view your Three.js app, you can just click preview, and then because we're running a script here, we enable scripts. So the difference that we have with Three.js in this case is it's still gone and done our kind of booleaning. It's made a texture, and we've got this regenerate button here, which is going to like randomly regenerate these forms, which I guess is the appeal of things like Three.js. So again, just like with Rhino, we'd be able to iterate on this, add things like drawing in our reference curves, or maybe even just importing our reference curves straight into Three.js. We could prompt this to be able to export the geometry so that we can get it back into Rhino. Really, the sky's the limit in terms of what you can do, especially combining these two things. Maybe you do Three.js for simulation, then bring the geometry into Rhino and then edit it with more Python scripting. So let us know what you make with the code editor in Discord, or if there's something that you want to know how to do, give us a shout.